This question is to determine the axis of symmetry between the graphs of two related functions. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Thank you so much. Let the domain of both functions, y equals g of x and y equals g of b plus x, be all real numbers, where b is a constant. Determine the axis of symmetry between the graphs of these two functions and briefly explain your reasoning. First step, we want to find a vertical line, which we can call x equals k, such that the graphs of y equals g of x and y equals g of b plus x are symmetric about this line. This means that the value of the function at b plus x should be the same as the value of the function at 2k minus x. In words, g of b plus x equals g of 2k minus x. Next step. Now, compare the parts inside the parentheses. That is, compare b plus x and 2k minus x. For the two expressions to represent mirror images about the line x equals k, they must be equal. Next step. Set b plus x equal to 2k minus x and solve for k. When you bring the x terms together, you find that 2k equals b. Therefore, k equals 1/2 of b. Next step. So, the two graphs are symmetric about the vertical line, x equals 1/2 of b. Final answer. The axis of symmetry is the vertical line, x equals 1/2 of b. The symmetry between a function and its reflected or shifted version depends on how the input is changed. When the input changes from x to a minus x, the symmetry line is x equals 1/2 of a. When the input changes from x to b plus x, the symmetry line is x equals 1/2 of b. In our case, because we compare g of x and g of b plus x, the symmetry line is at x equals 1/2 of b. When comparing two related functions, such as f of x and f of a minus x, or f of x plus b, imagine folding the graph along a vertical line so that one curve lies on top of the other. You can always find that line by equating the inside parts of the function expressions in mirror form and solving for x. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Copyright all rights reserved. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much. This question is to involve the dilution of orange juice to achieve a specific sugar concentration. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Copyright all rights reserved. Thank you so much. A fruit juice factory has 300 milliliters of orange juice with a sugar concentration of 10%. To produce a juice with sugar content between 7% and 8%, water, which has 0% sugar, is added. Let the added water be x milliliters. Which of the following intervals correctly describes the range of x? There are four options. First step, we calculate the amount of sugar before dilution. 300 milliliters multiplied by 10% gives 30 milliliters of sugar. Next step, the total liquid after adding water is 300 plus x milliliters. Then, next step, the new concentration must satisfy the condition. The fraction 30 divided by the total 300 plus x must lie strictly between 7% and 8%. So we set up the inequality. 0.07 times the total 300 plus x is less than 30, and at the same time 30 is less than 0.08 times the total 300 plus x. Next step, we solve the two parts separately. For the left inequality, 0.07 times 300 plus x is less than 30. This becomes 21 plus 0.07 times x is less than 30, which means x is less than about 129. For the right inequality, 30 is less than 0.08 times 300 plus x. This becomes 30 is less than 24 plus 0.08 times x. Subtracting, we get 6 is less than 0.08 times x, which gives x greater than 75. After that, next step, we combine the two results. The allowed range of x is greater than 75 and less than about 129. Next step, we compare this range with the answer choices. Only option B, which is 75 less than x less than 300, contains the correct range. Final answer is option B, 75 less than x less than 300. The key technique is always to translate a concentration problem into an inequality where the numerator is the fixed amount of solute and the denominator is the total amount of solution after mixing. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Copyright all rights reserved. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much. This question is to present a problem centered on identifying which of several given functions lacks an inverse. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. Determine which of the following functions does not have an inverse function. Show your reasoning clearly. There are 4 functions. First step, we start by recalling key idea. A function has an inverse if and only if it is 1-to-1, meaning that no 2 different inputs give the same output. Next step, we check each case. Case 1, y equals cosine of x, with x between 0 and pi. On this interval, the cosine function decreases strictly from 1 down to -1. Therefore, it is 1-to-1 and it has an inverse. Case 2, y equals x to the 5th power minus 3. The function x to the 5th power is strictly increasing for all real x. Subtracting 3 only shifts the graph vertically, so it remains 1-to-1. Therefore, it has an inverse. Case 3, y equals 1 divided by the quantity x squared plus 1. The domain is all real x. Notice the symmetry. For example, the value at x equals 2 is the same as the value at x equals -2. Since 2 different inputs give the same output, this function is not 1-to-1. Therefore, it does not have an inverse. Case 4, y equals natural logarithm of the quantity x plus 4, with x greater than -4. The natural logarithm is strictly increasing, and the domain restriction keeps it monotonic. Therefore, it is 1-to-1 and has an inverse. Next step, conclusion. The function that does not have an inverse is the one where y equals 1 divided by the quantity x squared plus 1. Students often forget that even functions, such as 1 divided by the quantity x squared plus 1, fail the 1-to-1 test because the outputs for x and -x are identical. Another common mistake is overlooking domain restrictions in trigonometric or logarithmic functions. Always test injectivity. If f of x1 equals f of x2 forces x1 to equal x2, then the function has an inverse. Otherwise, it does not. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much. This question is to involve the transforming functions with variable substitution. Let the function f be defined for negative values of x by the rule that f of 1 divided by x equals x plus the square root of 1 plus x squared. Based on this definition, determine the value of x times f of x. First step is to make a substitution to simplify. We begin by letting t equal 1 divided by x. That means x equals 1 divided by t. Now, using the given definition, f of t becomes 1 divided by t plus the square root of 1 plus 1 divided by t plus 1 divided by t squared. Since x equals 1 over t, we can now write x times f of x as x multiplied by the quantity 1 divided by x plus the square root of 1 plus 1 divided by x plus 1 divided by x squared. Next step is to simplify the product. First, x times 1 over x simplifies to 1. Then, look at the second term, x times the square root of 1 plus 1 over x plus 1 over x squared. We can write that inside the square root as a single fraction. The numerator is x squared plus x plus 1, and the denominator is x squared. So the square root becomes the square root of that full fraction. Now, multiply x by that expression. You get x times the square root of the fraction whose numerator is x squared plus x plus 1, and whose denominator is x squared. That simplifies to the square root of x squared plus x plus 1, divided by the absolute value of x. But since x is negative, dividing by its absolute value flips the sign, so we end up at the negative of the square root of x squared plus x plus 1. Finally, we combine the two terms, 1 minus that square root. When a function is written in terms of 1 over x, try changing variables first. It often makes the expression easier to handle. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to find the inverse of a square root function algebraically. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. Find the inverse of the function algebraically. Let the function g of x be defined as the square root of 12 minus 3 times x. Find the inverse function of g and state its domain. First step is to rewrite the function using y. We start by replacing g of x with y. So we say, y equals the square root of 12 minus 3 times x. Next step is to swap x and y. To find the inverse, we switch the roles of x and y, and now we say, x equals the square root of 12 minus 3 times y. Next step is to square both sides. Now we square both sides to eliminate the square root. This gives x squared equals 12 minus 3 times y. Next step is to solve for y. We isolate y by subtracting x squared from 12, giving 3 times y equals 12 minus x squared. Then we divide both sides by 3 to get y equals the fraction 12 minus x squared all over 3. Next step is to write the inverse function. Now that we've solved for y, we can write the inverse function of g as g inverse of x equals the fraction 12 minus x squared all over 3. Since square roots always give non-negative outputs, we say x must be greater than or equal to 0. Next step is to state the domain of the inverse. The domain of the inverse function is the same as the range of the original function. Since the original function outputs values greater than or equal to 0, we conclude that the domain of g inverse is all x greater than or equal to 0. Be careful not to forget squaring both sides, and always remember that the domain of the inverse comes from the range of the original function. To invert a square root function, first switch x and y, then square both sides, solve for y, and finally double-check the domain using the original function's range. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.